we go. Here we go. Now, you maybe didn't realize this, but you know how if I wanted to measure the distance from Samantha to me, I could measure that distance in feet, I could measure it in yards, I could measure it in centimeters. There are lots of units of measurement for length, right? Same thing with weight. We've got pounds and ounces and grams, lots of different units. Well, when we measure angles, there are lots of ways to measure angles too. You, in your life so far, have measured angles in degrees. Somebody says that's a 90-degree angle, it's a 45-degree angle. Well, the unit of measurement used from calculus on, nobody in calculus class ever talks about degrees. Everybody in calculus and beyond uses an angle measurement unit called a radian. All right, a radian. Now, what is a radian? I'm going to give you the definition of a radian just so you have some idea of what it is. The word radian is the measure of the angle. I know. I'm sorry about that back there. You know, you don't have to sit right next to it. There's some other empty seats. The measure of the angle determined by striking an arc of radius length. Now, what does that mean? Well, we've got a circle. And let's say the radius of the circle is, if we strike an arc that is 7 units long, so if this guy right here is 7, in other words, if the arc length is the same as the radius, then that is 1 radian. So if I made another 7, this would be another radian. So in other words, an arc of 14 would be 2 radians. Does that make sense? Do you see what I'm talking about here? Does that make sense? So the general relationship is that the arc length is going to be the radius times the radians. Now, I want you to write that down. I want you to write this down because that is going to be very useful to us. So 14, which is the arc length, is the radius, which is 7, times the radians, which is 2. 7 times 2 is 14. We're going to do some problems with that a little bit, but just hang on to that. Write that down somewhere on the color check or something. That's going to be bad for us. Okay, now another thing that you have to write down is that if we go all the way around the circle, how many degrees is that? All the way around the circle is 360. Well, all the way around the circle is 2 pi. So 2 pi radians equals 360 degrees. Most people reduce that and say pi radians would be what? If 2 pi is 360, 1 pi would be 180. Write that down. So just like 12 inches is 1 foot, those are equivalent. Pi radians is 180 degrees. Those are equivalent. Okay? So now we're ready to do problem number 1. We have written this down on our paper. somewhere, maybe here, maybe up here, I don't know, somewhere you're putting that down, you're putting that down. All right, so here we go. Man, it feels good to be doing this again. All right, so 100 degrees is how many radians? This is the question that we are being asked. Now, what does that say right there? Pi radians is 180. So if I build this fraction, pi radians, 180 degrees, those are the same. That's like one. Those balance each other. So the question is, if pi is 180, how many would be 100? Does that make sense? Pi is the same as 180. I want to know what is the same as 100. This will never change. This is fact. Pi is 180. Then, whatever the problem is, in this case, I'll say x over 100. Now, can anybody tell me why I did x over 100 and not 100 over x?
So you're solving for the radian?
Exactly. When you put pi over 180, this is a radian and this is a degree, right? So when you build your fraction, if you put the 180 on the bottom, which is where I always put it, you don't have to, but that's where I put it, then I gotta put my degree on the bottom. Now, how do I solve that? You guys know, that's a proportion. How do you solve a proportion? Cross multiply, very good. So I'm gonna cross multiply 180x equals 100 pi. And by the way, we're gonna leave pi in our answers. And then we'll divide. So we have 100 pi over 180. And then we will reduce our fraction. So almost always we're going to have zeros that'll cancel, not always, but usually. And now I have 10 over 18, which would reduce to 5 over 9. So I have 5 pi over 9. Don't forget the pi, it's still there. And there's the answer to the question. Okay, so now we're going to do the same thing with negative 60. All right, so we're going to set it up the same way. We're going to start with pi is 180. Now what? Pi over 180 is going to equal what? X over negative 60. And don't worry about the negative, it doesn't matter. My answer will just be negative. So then I'll cross multiply. Negative 60 pi equals 180x. I'll divide by 180. So it looks like my answer is negative. Did you get pi over 3 when you reduced it? Now this is day 1. So, you know, we're kind of still finding our way here. But I want you to think about this for a minute. If 180 is a whole pi, then what would 60 be? A third pi? Because isn't 60 1/3 of 180? Right? So you're going to get to the point where you probably aren't going to have to go through all this arithmetic, because you're going to remember that a whole pi is 180. So what would 90 be? If a whole pi is 180, then 90 would be half a pi? Sure. You can work it out if you want, but you can also just think about it. All right, would you do C on your own, you and your partner? Do C, you're changing 210 degrees. first? Terry Green, what'd you set up first? Okay. How does that look to everybody? Are y'all on board? So 180x equals 210 pi. What did I do? Not the right thing. I right by 180. Solving for x. There we go. So x equals, did you get 7 pi over 6 when you reduced your fraction? Easy peasy, right? So easy. All right, now we're going to go the other way. Look at part 2. Now, you want to change pi over 4 into degrees. You can set up a proportion like this if you want to, but don't, because it's way more work than you need to do. What is a whole pi? How many degrees is a whole pi? 180. This is a fourth of that. See how that's divided by 4? So this is 180 divided by 4, which is what? 45 degrees. You'll have a baby calculator, by the way, to do this, so feel free to be typing it in on your calculator to help you with the arithmetic. 2 pi over 3. Right, now let's just gather ourselves and pause for a moment. What is pi? 180. What would pi over 3 be? 60. But I got 2 of those. 120. Wow, that's even easier than this was. Negative pi over 6. Okay, so what's pi? 180 divided by 6. 30. Negative 30 degrees. Try to get in the habit of putting the degree mark on your degree measures. I sometimes forget, so I can't yell at you too much about it, but try to get in the habit of putting a degree mark if you are doing a degree. There is no label for radians. Okay, there's no label for it, so it's just negative pi over 6. All right, 7 pi over 6. Here we go. What's pi? 180 divided by 6, 30 times 7,
Or 210.
210. Oh no. Look at E. 2 radians. Uh-oh, that looks different. There's no pi, so I can't substitute in 180. Any thoughts on what I'm going to do? I'm going to set up my proportion. So pi is to 180. Now, what's my other fraction going to be? Is it going to be 2 over x or x over 2? 2 over x. And why is it 2 over x? Because that's 2 radians. And this is where the radians are. This is the degrees. So I'm going to have 2 over x. So pi x equals 360, cross multiply, and divide by pi, you're solving for x. So it's 360 divided by pi degrees. And then F is so easy. How many degrees is pi radians? 180. Yeah, that one's just 180. All right. You know, on an old-fashioned clock, like on a real clock with hands and stuff, you have all the way around is 1 hour. But that 1 hour is split up into littler pieces called minutes. And there's 60 minutes in an hour. And then the minutes are split up into even smaller pieces called seconds. And there's 60 seconds in a minute, right? You're all familiar with that concept. Okay. Believe it or not, the same is true of degrees. A degree can be split up into 60 parts called minutes. It's just like an hour. So 1 degree can be broken up into smaller pieces called minutes, and then minutes can be split up into 60 smaller pieces called seconds. So degrees can be broken down into smaller units. Now, you and I, when we draw our little triangles, we don't really have a need for that. But people who sail or fly around the world have a need for that. Because if you think about how big the world is, that's the world. That's really big. If I do 1 degree, that's a big space, right? So if this ship is trying to figure out where that ship is, we need a more precise measurement. So we might say, well, we're not 1 degree apart, we're 1 degree 4 minutes, and that little hash mark is the minute mark, and 16 seconds. And then if we have this big, vast distance, we can narrow it down better because we're using smaller units of measurement. If you've ever watched a movie or something where the maybe co-pilot is talking to the pilot or a ship captain is talking to a sailor, they'll tell you their latitude is 58 degrees, 10 minutes, 13 seconds. That's how latitude and longitudes are labeled. So, back in the old days, when I was doing all this, we had to do all that by hand, but you have a calculator that will take whatever angle you have and break it down into degrees, minutes, seconds, and vice versa. So let's get our calculators out. And if you came unprepared today, let's come prepared tomorrow. So lean over, watch your neighbor, but we know that it doesn't work unless you're doing it yourself. So from now on, we're gonna have it, hang on. Hold that up so everybody can see it. Is it turned on?
Yeah.
You're amazing, thank you. Thank you. All right, first thing I want everybody to do is go to mode. Go to mode. You got it? Your mode. And if you look down, for me it's the 3rd row down. I'm not sure where it is for you, but you see how you have a degree and a radian? You need to have degree highlighted. All right, so click down, highlight degree. Okay, and then just second quit. So we're all in degree mode because we're going to be putting a degree into our calculator. Okay, so now what I want you to do is type 100.4. That is the problem. I'm on 3A. That's the problem. So I'm typing 100.4. That's it. There's 100.4. Okay, now if you look, you have a button that says apps, APPS. It's right here where I'm pointing. You find it? And right above that button, it says angle. This is our angle menu, and we're going to be using it a lot. So press second, apps, That brings up your angle menu. And if you look down that list, one of the options is DMS. What does DMS stand for? Degrees, minutes, seconds. So if you just click down there and press enter, and then enter again, it tells you that 100 degrees, or 100.4, excuse me, 100.4 degrees, that was our problem, is the same as 100 full degrees, 24 minutes, and no seconds. All right, let's try that again. Let's type in 18.375. And then second angle or second apps. Go down to DMS and press enter until you get something. So 18.375 degrees is 18 whole degrees, that makes sense, 18 degrees, 22 minutes, and 30 seconds.
Joe's writing it like that on the test.
Yes, that's exactly how you write it. All right, you and your partner try the last one. Go ahead and type the negative in, it doesn't matter. It won't hurt a thing, go ahead and type it in. See if you can come up with the degrees, minutes, and seconds for negative 20.42. Very good. All right, Gannon got negative 20 degrees, 25 minutes, and 12 seconds. What about you?
That's what I got.
That's what you got.
You're smart, man.
Moving up in the world, man.
Yep. Okay. So if we want degrees, minutes, and seconds, we use our DMS button. That's how we get degrees, minutes, and seconds. All right? Now, the next exercise says, use your calculator to convert to decimal degrees. All right, so this guy right here, the number you were typing in on your calculator is a decimal degree. We changed that into degrees, minutes, seconds. Now we're going to do the opposite. Now we're going to take 132.11 and we're going to change it into a decimal. Okay? So type 132. Just 132. Got it? Go back to second angle. And the very first thing at the top is a degree mark. Right? Press it. So now your screen should say 132 degrees. Now, type 11. And then second angle again. And what is right under the degree mark? The minute mark. So go down to minutes and hit enter. And you get 132.183 repeating degrees. Would you agree with that?
Yeah.
So you started with degrees and minutes, you ended up with a decimal. All right, let's try the next one. 18, 12, 13. 18, 12, 13. All right, so let's see. First thing we'll type is 18. And then second angle, degree. and then 12, second angle. Now I know I'm gonna choose my minute mark, but before we do that, I want you to notice what is not right under the minutes. What do we wish was right under the minutes? But it's not there, all right? So we're gonna have to go somewhere else to get that. But we need the minutes now, so go down and get the minutes. So now I have 18 degrees, 12 minutes on my calculator. Are you here? All right, so now I type the next one, which is 13. Okay, now this is where things get completely wacky, crazy. I have no idea why. Look above your plus sign. Find your plus sign on your keys there. See your plus sign? Now mine's green, but right above the plus sign, you see the little second mark? So you're going to alpha plus, and that's where you get your second mark. Okay, and then enter. And did you get 18.2036? All right, with your partner, DC.
The trifecta.
You got an answer. What'd you get? Negative 152.3108. Yep, good. Perfect. All right, everybody good? All right, here we go. Number 5, find the missing variable. So first of all, we got a picture that looks like this. Got a big circle, got a piece of pie, pumpkin pie or something here cut out. This is our central angle, which we're gonna call theta. This is a Greek letter, theta. And since the ancient Greeks were the source of much of our trigonometry, we use the Greek alphabet a lot as variables. So that's like an X, it's an unknown. That's your angle. Now, that angle is always in radians, okay? That central angle needs to be in radians. This obviously is the radius of the circle. And then S is the letter that your textbook and others uses for arc length. So this is S right here. Now wait a minute. Angle, radius, arc length. On your notes, I told you to write something down and box it in. What did you write down and box in? Arc length equals radius times radians. That is how I remember it, but if we do it in terms of the letters in the problem, it would be S equals theta R or R theta. I don't remember that. I remember this right here, but you remember whatever you want. You need to know that. Okay? So if we know that, then these problems are easy. Problem A says we have a circle. Radius is 10, angle is 2, and we want to find arc length. Well, shoot, kids, that's easy. arc length, I'll say S, equals the radius times the radians. So isn't the answer just 20? Now, one more piece of information. If this had been 10 inches, there's no label on it, but the radius has a measurement, 10 inches, let's say, then the arc length would be 20 inches. Arc lengths have measure of units, just like radiuses do. All right, how about B? Same picture, same idea. This time, the central angle is 1.5. The arc length is 6, and I need to find the radius. What's my formula? Arc length equals radius times radians. Does that make sense to you? So what do we do to find R? We need to figure out what R is. So we'll divide. Is that 4? All right, do C. Do letter C with your partner. Same exact idea. I hope you and your partner said 10 equals 4 theta. So theta equals 10 fourths, which will reduce to either 5 halves or 2.5, depending on whether you're using a calculator. You good? Okay. Now you got a curveball thrown at you. Look at letter D. Tell me what is different about letter D. The angle is in degrees. What's our formula? Arc length equals radius times radians. There's no room for degrees. So what are we going to have to do? Change that angle into radians. And do you know how to do that? It's the very first thing we did. The very first thing we did. So over to the side, this is not the answer. We're going to say pi is 180. So what is 30? Remember doing that first thing? We need our angle to be a radian. I don't know. I got 30 degrees, so I'm going to figure out what that is. So 180x equals 30 pi. Divide by 180. Cancel my zeros. It looks like x is pi over 6. Two things. Is that the answer to the problem? No. I'm supposed to be finding my arc length. So that's just the background work. Second thing, did anybody, without doing this work, did anybody know that was going to be pi over 6? Okay, remember, what's a whole pi? 180. Isn't 30 a sixth of 180? So you, again, you don't need to do this if you can just know that's going to be pi over 6. But it is pi over 6. Now I'm ready to find my answer. Arc length equals radians times radius. So radians times radius. So that's 10 over 1 times pi over 6. So 10 pi over 6. Straight across, 10 pi over 6. And what does that reduce to? Five pi over 3. And that's the answer to the question. Now, before you guys, some of you are starting to get a little bored, you can go tune me out. Just think about those poor kids next year. They're gonna have to sit here for 85 minutes. All right, last one in this section. Here we go. Angle is 90 degrees, arc length is 10 pi. We want to know what the radius is.
Do you want the answer as that, or can we put it into a decimal?
No, it's this. We leave our pi's. And again, if this had been 10 feet, then that would be 5 pi over 3 feet. Your arc length unit matches your radius unit. Okay, when you see a degree measure inside there like that, you're immediately starting to twitch. You can't have a degree because your formula is arc length equals radius times radians. So I know my arc length is 10 pi. I don't know what my radius is, but I know the radian measure. Come on, can we do it without working it all out? It's 90 degrees, which is half of a pi. How do we know that? Because a whole pi is 180. So 90 would obviously be half of that. Oops, that's a times pi over 2. So I don't want a 90 here. I want pi over 2. Half a pi. Okay? Now, your job is to solve for R. Some of us are a little bit nervous about arithmetic, so let's do this easily. Let's multiply by 2. Because if we multiply by 2, that will take care of that fraction. So 20 pi equals pi r, pi times r. I'll divide by pi. And it looks like r equals 20. You do not have the book open, and I don't want to take time to open it. Well, first of all, I don't have it. I don't have second semester loaded in, so you couldn't open it anyway. So I'm going to draw the compass for you that we're going to use all the time. Okay, it's the same compass we use all the time. So I'm going to draw it nice and big. And I know, actually, I'm not going to draw a circle. Here's my compass. And you know on the compass that this is north and south and east and west. And if you don't know that, you need to know that. That's something we should just know. Okay? Now, angles are measured from angles for navigation. When we're doing directions with a compass, they're measured from due north. So this is 0. And they go clockwise. So that's 0, 90, 180, 270, and of course this would be back to 360. Okay? Now, you're smart people. You know that if I split this exactly, make this a 45-degree angle, this direction would be called northeast. Is that okay? And then I'll split this one. So this would be southeast, and what would that angle be? Remember, you measure from up here, due north. So what would that angle be? 135. How did we get 135? Well, to east would be 90, and then we went 45 more. We're splitting these in half. All right, what's this guy? This guy would be southwest. And what would his measure be? Hey guys, how far is it down to south? 180? And then another 45? So 225. And then how about northwest? 315, I heard somebody say it, 315 degrees, that's right. When the quadrants are 90s. When you drew in these blue lines, I split the quadrants exactly in half. So each of these angles here is 45. So to figure out these numbers, I just went all, like this one right here, I went all the way to 180 south, and then added a 45 to it. Okay? Now we're going to split one more time. If I draw this guy in right here, how big is that angle right there, that little tiny angle right there? How big is that? Well, how big is the blue angle here? 45. I cut it in half. So 22.5. So this guy right here is 22.5. Now, how do I talk about that direction? Well, if I draw in that purple line and this purple line, these are all 22.5s, okay? Both of these purple lines are in the northeast quadrant. Would you agree with that? This one is on the north side of the northeast line. So here's the northeast line. This is on the north side, so it is called northeast. Guess what this one's called? East northeast, because he is on the east side of the northeast line. My arm is the northeast line. This is on the north side of it. This is on the east side of it. So north northeast, east northeast. Now, what is the degree measure for east northeast? What?
The same thing.
Well, these are all 22.5, but I need to get all the way to here. Now remember, you start at due north, you start at 0. So this one is 22.5. This one's 45. What's this one? 67.5. How did we get 67.5? Well, two different ways. You could take 45 and add another 22.5 to it. Or you could say, well, I've got 3 22.5s, and that would give you 67.5. All right? Now we can do that process in every quadrant. Let's look at the problems. So we're not going to do every single one. Let's look at the problems. East, southeast. Okay? Where is east, southeast? Well, here's southeast, right? If I split this quadrant, is this one east, southeast? Or is this one east, southeast? Which one, the top one or the bottom one?
Top.
The top. This is on the east side, it's between east and southeast. So it's east, southeast. And how big is its angle? Now remember, you're coming all the way around. 112.5, and how did you get that, Armani? 90 plus 22.5. Just for fun, what's the name of this line? South, southeast, perfect. All right, let's do some more. Southwest. What is the angle for southwest? Southwest is 225. We already figured that one out. This is southwest. West, northwest. West, northwest. So here's northwest. Here would be one split. Here would be another split. Which one, top or bottom, is west, northwest? Bottom. Now remember, you want to label that. You got to come all the way around to it. Any thoughts on what that is? 292.5. Armani, you are on fire. How did he get 292.5? I don't know. He could have taken 270 and added 22 and a half. And then this guy up here is north-northwest. Would you agree with that? And what's his measurement? You could take 315 and add 22 and a half. Or you could take 360 and subtract 22 and a half. Either way, what is it? 337. Shoot, we have one more section, so no homework tonight, but you can get started on it because we only have one more problem to do. Okay?